Hi and welcome to a new video, and this time I'd like to talk about my new released asset, and it's called SimpleWebRTC. And this is a Unity-based WebRTC wrapper, which allows you to use the Unity WebRTC package to establish connections for video, audio, and data transmission between clients with the help of WebRTC peer-to-peer connections. It uses native WebSocket for the WebSocket communication, which is only the signaling server for establishing WebRTC connections itself. And it's a one component rules all solution. So you will only need to use one component called WebRTC connection. There are a lot of settings, a lot of events, and a lot of stuff you can use. And I'll try to upload videos soon, how you can modify it to use it for other needs than just a simple camera and audio streaming, for instance, using the webcam image or using the microphone input to build a simple video call solution here. But for now, let's just hop into Unity and check out the asset. So the asset comes with a few scenes. I'll just change the window size here. And let's start with the simplest scene, which is called WebSocket test connection. So first of all, when you import this package, you can either go to the GitHub repository to the releases section. Here is the initial release. You can download the Unity package to import into your Unity project, or you download it from the Unity Asset Store. I'll add the Asset Store link as soon as the publishing process is finished. You can nevertheless use this one for now. And after you imported it, you will have the SimpleWebRTC folder here. And there are setup instructions on GitHub. For the simple installation, make sure to install the package and all the dependencies like TextMesh Pro, Unity WebRTC package, and native WebSocket. So for the manual installation or via the release page, go in your Unity project, go to Window Package Manager for in project and check if Unity WebRTC is installed and native WebSockets are installed. These two tools are needed to work properly. If you're going to use the Unity internal web server, you can also install WebSockets sharp. A short tutorial how to create that server will be at the end of the video. But for now, let's go with native WebSockets and the online solutions. When using native WebSockets, it's fairly easy to install it. You can just open the package manager window and click on add package from Git URL and enter this URL. Click on OK, and it will be added to your project. And for installing Unity WebRTC, which is actually a requirement for this package, it should be prompted automatically. If it's not, you can go to the package manager again, add package from Git URL, and add this link here, add the Unity package directly to your project. Also make sure that TextMesh Pro is imported. You can go to Window, TextMesh Pro, import TMP essential resources. This should also be prompted when installing the SimpleWebRTC package. If not, you have to do it manually. So first of all, what is WebRTC? WebRTC is a standard which allows you to add real-time communication capabilities to your application. In this case, we're talking about Unity and all the platform it supports. For the supported platforms, you can check the Unity package site. Here we go. It's Windows x64 only, Linux, macOS, iOS, Android, ARM64 only. Windows UWP is not supported, iOS Simulator is not supported, and the WebGL is not supported. While being for WebGL, you would use the web solution nevertheless, but from within Unity, these are the only supported platforms, and there are a few settings to make when building for this. IL to CPP scripting backend, ARM64, and they require for internet access in the place window. Same goes for iOS. In the Xcode build settings, enable bitcode to no, and there are a few more references here, but that's basically it. All you have to set up, and you can use WebRTC from Unity in your project. What can WebRTC do? From video to audio and data transmission, And there are a few guides on the official WebRTC.org page where you can get started, like having media devices capture that streams and send them over WebRTC. This is a pretty good guide. It's in JavaScript because WebRTC for web solutions and so on. And this should help you to get a proper understanding if you're not interested in learning all those things, like what is a peer connection, how does the signaling work, or how to send data between two peers, how is the communication built up, and so on. You can more or less skip it, although I recommend reading the Get Started with WebRTC page to just have a grasp of what is even going on here, where does WebRTC come from, and what is a peer connection, and so on. The WebRTC peer connection does not define something like the signaling, which is required for having every client know about the other clients. This signaling will be done by WebSockets here. I'm using a glitch online WebSocket server. How you can set that up, and on the end of the video, and the same goes for Replit. But there are also solutions for local server, and there is also a section at the end of the video which show you how to set up a local node server, which will do all the signaling for you. The code is provided here in the Signal server code text document. You will just have to set up a project, copy paste this one, and your server will run. That's actually pretty cool. And there is a connection test seen here, which allows you to check if your WebSocket connection is working. I have a glitch server running under this address for secure WebSockets. I will have to use the HTTP header, otherwise glitch will not let me communicate with my WebSocket server. And if I start the scene, assuming that my web server is running, the connection is opened. So you can use this to check if your server is reachable. Always make sure to use WebSocket here or WebSocket Secure in this case. Do not use HTTP or HTTPS here because this is the wrong protocol and we want specifically this WebSocket connection. Let's just check out the source code real quick because it's fairly easy even for people who don't code on a regular basis. It's like we're having a WebSocket. Depending on if we need the HTTP header or not, we're just sending additional header data with it or not. There is an event for open, on error, on close, and on message. This means you can send messages. This will be our main signaling mechanism to inform every client of every other client to establish peer connections. Then I'll just send WebSocket messages every 0.3 seconds, or in this case, every second. Repeat rate every second. So the comment is wrong here. And then I'm waiting for the WebSocket to connect. So if I have multiple connections to my WebSocket here, they will send messages every second. Let's try if we can do that. We just duplicate the connection test object here, start. Connection is open, and we see that there are messages sent every second. As these two are activated at the same moment, the two messages will always come in here, 2 and 4 messages, because I'm sending, each client is sending a string message and a byte message. Just play around with it, deactivate that, and start again. One client will connect first. The second client will connect a little bit later, and we'll see that the timing is slightly different. So it's that easy to establish a WebSocket connection. The web server, as I said, is running on glitch. Just open it. So this is our glitch web server. As I said, the code is within the package. Everything is set up. How to set this up is at the end of this video. And the logs already tell us that there was a client which was connected, 2 clients who connected and sent some messages here, and the client is connected afterwards. So fairly easy. That's a WebSocket connection. And going one step further, we now want to have some kind of WebRTC connection. So there is the scene WebRTC single client stun connection. And this is already a very simple implementation of a WebSocket WebRTC client app, which will use an online WebSocket server for signaling. Just click here real quick, online web server for signaling, and a stun server. This is one of Google's free stun servers for all the handshaking, transmission, and so on from the video data for establishing the WebRTC connections themselves. So let's dive a little bit more into this component and what you can do with it. As you saw the demo in the beginning, you can use this scene, build it, for instance, for Android. I already have the Android platform selected here, and use it on an Android device to transfer video from either from Android to the other clients or from other clients to Android or whatever direction of signaling, whatever direction of transmission you want. And the secret is that this WebRTC connection component uses this WebSocket server address, a stun server address, and a local peer ID, which must be unique for each client. So in case you wondered why the cube is switching colors, there is this random color client cube script, which also lets the cube rotate and sets a random color for the cube, but does not change the local PID. So you can either change this manually, or there is a method in the WebRTC connection script which lets you change the local peer ID. Again, make sure this is unique. I decided against the GUID here because sometimes you want to have a player name, a unique player name, which you want to display and not handle player name, unique IDs, and so on. But you can also use a unique ID here, so no worries. The next tick, the use HTTP header, is especially important when using a glitch web server because glitch only lets you connect to its machine if there is a certain header included. Other platforms like REPL or local machine would not need that header up, but it doesn't hurt to send it, so you can just keep that activated. And I created a simple logger class, which will log the WebRTC connection state and the data channel logs for test messages and so on. You can untick them. I will just keep them ticked to have a fairly good overview of how the WebRTC connection state is. If you're using this for debugging, for instance, just make sure to untick them to not be fully cluttered in your console. And everything else can be done by a script too. I'll just show you the easy way how to do things in the inspector, and we'll deep dive in the code a little bit later. So usually the three checkboxes you need are WebSocket connection active. This is this one. The video transmission start stop tick and the audio transmission start stop. Everything else is just for indication purposes or for event handling, so you can register your own event receivers here. The WebSocket connection usually waits until there are more clients and will figure out the WebRTC connection from it for its own. So if we're, for instance, using a second client connection, disable this one and start with one client connection, assuming that the glitch server is running. This one here, just clear the logs and start our application, then this stun connection will connect to our WebSocket server as soon as we tick this WebSocket connection active, this one here. So we'll see there is WebSocket connection opened. The WebSocket server tells us there's a client that just connected. And if we open the second connection and set that tick active, we see that a lot happened here. And even if we check out our signaling server, all the signaling is done. And one of the last messages here is the complete message. And even in the Unity logs, here is our complete message, and the default changed to completed. So there is a peer-to-peer connection established. These two are connected, although they have the same peer ID. This works with two clients, but not with more. So we would just want to change that to, I don't know, let's call it green peer ID. So let's do it again, just to have a better understanding of everything. First client, please connect. Second client, activate, please connect. And when everything is finished, you will see that the WebRTC connection active checkbox is ticked on both clients, which will now allow us to send test messages, for instance, over the data channel. There is also a method to send your own string messages over the data channel, and you can start video transmission, for instance, start and receive video transmission. You will now see only one of these two because they're on a canvas over here. So if I move that a little bit more to the side, you can see there are actually raw images for each client, which will receive and transmit the audio and video. And that's a very simple way to use this asset. So usually it's enough to have something that sets a unique peer ID, have a client-stem connection here, and at a certain condition, in this case, it's just a click of a button, in this case, the connect button, which we'll call WebRTC connection.connect. And it will connect to the setup server, either it is in the web or local stun server. If present, if you don't need the stun server here, you can just delete that too and set the local peer ID, and everything should be working out. So in case you're not interested in the simple stun connection and in a very easy way to use it, there is another scene here, which is called the single client with lobby, which looks basically the same here, but works like a lobby client where you have a simple lobby manager, which will handle a little bit more of these connections, where you can set up the UI to react accordingly to your clicks. And if we now use our Android client with this scene, you can check how a simple lobby would work, where you can even set a simple player name. Again, I just added a player name here and set the machine name to make it unique, and they can communicate over the net. So I'll show you that right now. So again, I'm having my smartphone here, which is basically on the public net. My PC is within the local area network. You can see here that I have a 5G connection, and this is my web server running on Glitch. And if I now click on join lobby, I will be joining the lobby, and I'm waiting for the next client to join. So click here on join lobby, connecting, and I have my connection established, and every participant can now send messages for the chat messages. In the chat, please send me your video and audio, and I'll say on my smartphone, okay, I'll send you my video, I'll send you my audio. Just stop the audio here so I can talk a little bit better, but we can try, if we really receive the audio here, restart it and try to reduce the volume on the client side. Let's do that. And as you can hear, I reduced the volume here on my client side. So the transmission from my Android phone to my PC is working. You can see it in the video too. So if I start video on my PC side here and start the audio on my PC side, this will work too. I can stop it. I can stop it here. I can send the chat message again, or leave the lobby and rejoin the lobby. And now I can again send chat messages, start my video transmission, start here, and on the other side too. Start video, start. And this is open for every client who can connect with this lobby scene. Again, this is a simple lobby. There is no real chat for this, but it's working and it's using WebRTC which makes it simple, for instance, for you to transfer your video from, I don't know, your client on a VR glass on a MetaQuest or something to an Android phone or to a PC user who should enjoy the same view as the VR user. Okay, let's close that down and check out one more sample scene, which will be in the package. The last scene is the multiple clients done connection, where I used, let's fix this to landscape, 3 single connections, which will connect to the same WebSocket stun server and have different local peer IDs. Like, for instance, it's the red peer ID, it's the green peer ID, it's the blue peer ID, and they will connect one after another and can share their videos and their audio. So let's get started. I'll just open the scene. As you can see, the WebSocket connection active tick is already active. So if I enable the game object now, it will connect to the web server. It's unable to connect to the web server. But as you see, we're using glitch here. So I will have to include the HTTP header. Otherwise, we will get this unable to connect to remote server. And if I now start it and activate the object, I can connect. I connect the second client and the third client too. And now I start the video connection on all, video transmission on all 3. Red, green, and blue. And the background indicates who is the sender. The senders are over here. So red is the sender, red receiver, blue sender, blue receiver, and the same for green, green sender, green receiver, green receiver. Okay, same as for audio. It's a little bit hard to hear because it overlaps so much, but there is definitely an audio transmission. And as you can see, this works with multiple senders and receivers. And as soon as I disconnect a connection, it will stop transmitting the video. And as soon as I connect it new, it will be able to transmit the video again. Oh, I have to activate the WebSocket connection here. You can see, okay, now I can transmit it again, and the others are not aware that this is already available as a client again, so we'll just have to restart the video connection, and everyone is sending and receiving again. Just as information, I may add this automatic restart for the video transmission in future. At the moment, I decided to leave it like that to make it better handleable for others if the connection is really not wanted to be reestablished. For instance, if we connect this one, that this will on reconnect not automatically directly reconnect here. So we would have to set up the WebSocket connection, and on that, to avoid confusion, you have to start everything manually now. But we'll see how this will turn out and what the future updates will bring. This is, for now, a simple walkthrough through the component. And again, it's just a WebSocket server address, stun server address if needed, a unique local peer ID, a header when needed, the logs, a WebSocket connection active tick for activating everything. The rest are indicators. This is an indicator if the WebRTC connection is active. You can send a data channel test message here. This will be usable for you. Start stop video transmission, start stop audio transmission, and there are events as soon as data is received in data channel, video transmission, and audio transmission. And for data channel and WebRTC and WebSocket connection, you will have events to register when the connection is established. So this time I'll show you how you can create a simple signaling server with Node. And first of all, I just created an empty folder here. Started Visual Studio Code. Now we're starting with npm init. And this will walk us through the process of creating the project. You can just press enter on everything. Is okay, yes. And we'll now create an index.js. Index.js, this will be our start file. And going back to the terminal, npm install express for having the server components, and npm install ws for the WebSocket library. So everything is installed now. We can have a look under the package.json for our dependencies. And we're just pasting the code for the server here. Just move the terminal down a little bit so we can see it better. This code is added in the package, and on the GitHub repo as a text file, you can just take it and paste it, and this does nothing more than starting a server, tell us that the Signal server is running, creates a WebSocket server, and forwards all our messages to every client except the sender. So we're now typing in node index.js. Okay, we have to save it first, of course, and then type it again. We see that the server is running, and if we now open a browser, we see that our Signal server is running. So if you want to stay in C# or in Unity, you can use WebSocket Sharp as your server and client implementation. Be aware that it's not possible to modify the HTTP headers within WebSocket Sharp, so it's not possible to connect to Glitch, for instance, or a WebSocket server which has similar limitations, but usually it works pretty well. So when looking at WebSocket Sharp, there is a little bit of setup to do. There is a tutorial for that, but basically it's just downloading the project, building the assembly, copy that into your Unity project in the plugins folder, and it's ready to use for Unity. Here you go. And it's actually pretty easy to build a client and a server here. I added a simple implementation here. So you need the WebSocket server from WebSocket Sharp, an IP address, a port, which will be started, be careful here, as a WebSocket, not HTTP, not HTTPS, as a WebSocket. Then you will have to add a service here and start the WebSocket server so that every client can connect via this address. And on destroy, we stop the WebSocket server. And the simple service is basically the same as we saw in the other server implementations, starting our WebSocket behavior. And every time we get a message, we will forward this message to every client except the sender. And with this implementation, you can just keep everything within Unity. Be aware that it's not possible to run a WebSocket server on Android or mobile devices. You will have at least to use a PC for that. For creating a new server on glitch.com, we're just going over here, new project, glitch hello node, and then wait for Glitch to create our new node project. And after Glitch has finished setting everything up, we're going over here to package.json and add package via this button here, and we're adding the WebSocket package. The Express package is installed by default, and your package.json should look something like this. We can delete everything except the server.js package.json, and I kept the environment gitignore and license file here and just renamed it to something a little bit more appealing. And the server.js file has the same code as that one that is delivered with the package. It's a text file within the package, and it does nothing more than require Express starting an HTTP server, which will be converted to HTTPS automatically because we're on Glitch, and creating a WebSocket connection. This WebSocket, again, will just forward all the messages to every client except for the sender. And when we navigate over here, HTTPS Unity WebRTC signaling glitch.me, the Signal server is running. That's how you create the server on Glitch. If you want to use another web service platform, you can use applet.com, which is very similar to Glitch. It has a few other limitations and a few other benefits, but the process itself is basically the same. You can create a new node server. Then you will add the WebSocket dependency here, and you add the code, which is provided by the Unity package. which just starts an Express server and the WebSocket server and will forward all WebSocket messages to every client except the sender. And if you open the console over here and click on Run REPL, you will get a unique link to your REPL server, which you'll have to paste into the WebSocket server field of the client WebRTC connection component. Let's check. Go, Signal server is running, and over the link over here, you can connect to this WebSocket server. To just give you a very simple example, I opened the WebRTC multiple clients sample scene here, which is available within the Unity package, and I selected every client here and changed the WebSocket server address to my WebSocket localhost port 3000, and we don't need a stun server address for this one. Every peer has its unique ID and the default setting active. So as soon as this is activated, it will automatically connect to the WebSocket server and try to find other peers to establish a WebRTC connection here. So let's check our WebSocket server first. It's running on localhost 3000. That's good. And if we now start Unity, enable the first connection, we see a WebSocket connection is opened, and then we enable the second connection. We see that there is already happening something in the back. So WebRTC does work, and if we start the blue connection, everything should work as well here. Yes, nice. If we check out the console here, there was a lot of signaling done. To better read it. There's a lot of signaling going on, and if we now switch back to Unity and, for instance, start the video transmission on the red side, we see that every other client receives the video transmission from red. Same goes for green. This is the sender up here. Red sends, green, blue receives, green sends, red, blue receives. And if we start on the blue side, the same is here. We can stop the transmission. We can restart the transmission, and the same goes for audio. It's the difference to here is a little bit different to here, but the overlaying audio does sound a little bit strange, and it can be done from every client. And even if a client disconnects like this and reconnects and starts the WebSocket connection, we see that they're basically reconnected, and if we now start the video transmission, every other client will receive that. One downside is that we have to restart the video connection in the other clients too. So stop it and restart it so that the newly added client can also receive this video transmission. Same goes for audio, and that's it basically. I hope this asset will help you create your WebRTC or video and audio transmission for your app. And the best thing is this asset is free under MIT license. It's on GitHub, as you can see here. And it's on the Unity Asset Store. So as soon as it's available, I will add the link to the video description. Feel free to use it from the releases section 2. And I will try to update the tutorial series with, for instance, having some kind of video chat, audio transmission, integrating something like that in your game, and so on. Stay tuned. Tell me what you think about it. Tell me if you like it. If there are any issues, use the issues section of GitHub. And last but not least, thank you for all the channel members on YouTube. You're really helping me out here. You're really doing a great job in supporting the channel. It really helps. So if you're not a member yet, consider to become a member, or at least like, comment, and subscribe to the channel. And that's it for now. I guess I'll see you in the next video. Bye-bye.